Hello and welcome to Two Dancing Clams. In this video we'll create a procedural generator for mushrooms using geometry nodes in Blender 3.3. The following features from geometry nodes will be explored. Curved mesh, used to create a curved surface. A process for solidifying a surface in geometry nodes. Very proud of that one. Several different ways to use raycasting, make big use of the transfer attribute node, and also make extensive use of procedural textures. My primary interest in Blender, the way I got started, was for creating fantasy world. So if I can create a mushroom in a modeler in 4 or 5 hours, that's fine. But if I could spend a couple of days and create a generator for mushrooms, that's amazing. Because now my mushroom, I could build a mushroom forest, I could build a carpet of mushrooms on the ground, I can put mushrooms on the table to be eaten. This is the mushroom generator in its final form. Inside the geometry node, I've created a series of parameters. So the shape, color, conformation of the mushroom can be changed easily. So for example, we can add a little bit of bending to it to get a little bit more crazy mushroom, change the number of gills if you want something like really lacy or very spare. I really love the ability to change the color. When I'm creating a set and I want like a certain kind of mushrooms over here, maybe they're all brownish, and another set of mushrooms over here and they're all reddish, very quickly being able to come in here and alter the color of the mushroom without having to go down to the geometry nodes or without having to go into the texture editor and replace the texture. The other thing, we can control the stem thickness to get more petite mushroom or thicker one. The cap height is pretty powerful. It controls the height of the cap from the top to the bottom, but when it goes negative, you can also use it to reverse into the more cup-shaped mushrooms or downwards into the more button-style mushrooms. And of course, that can be accentuated by turning down the size of the width of the cap. Now, the first thing that's going to happen when we start creating the geometry nodes is we need a way to generate this shape here. And actually, we need to generate a way, to generate the other shapes that we just went through. It's like we need upward carving. I want something that like curves in on itself almost all the way. And I want to be able to generate something that's flat. When you look at the options that geometry nodes supplies, we could use a spiral. I tried that for a while. There are two things about a spiral that make it ill-suited. One, it's very hard to control the beginning position of a spiral and the end of it in XY coordinates, and we absolutely need the curve to start at x equals -1 and finish at x equals 0. We'll get into that in a bit. Could use an arc, but arcs follow circles. You can force one point to the origin, but again, it's kind of finicky to control. The key to getting the curve right for the mushroom cap shape is just a little bit of trigonometry. If you don't like math, you don't worry about it. Just scrub forward until you see the geometry node stuff start. If you do care about math, I'll cover this in about 2 minutes. So the typical formula for a circle is x squared plus y squared equals radius squared. That's all great. That describes a perfect circle, but it doesn't give us the things we want. For one thing, I want an equation that says x equals. I want to take a formula and get x out of it, and I want to take a different formula and get y out of it, and those are the x and y's that I can use to create geometry. Fortunately, polar coordinates provides a way to do this. So in polar coordinates that consist of a radius and an angle from the origin, a circle is described as x equals radius times cosine theta, and y equals r times sine theta, where theta is the angle around the origin from 0 to 360 degrees, or as it is more commonly inside Blender, 0 to 2 pi degrees, because they like to use radians. Now, this is a circle. We don't want a circle. We want like an arcy, spirally kind of thing. But that's easy because we will be creating this using splines, and splines give us a factor from 0 to 1 to the end of the curve. So we will replace this r, which is a fixed radius, with the factor from the spline. We will multiply by the factor, which starts at 0. So at first, everything will be forced to 0. And then as the factor gets bigger, we will arc away from 0. And then we can apply various multipliers to set the width and the height to get like the cap width and the cap height, as I showed you earlier. Easy peasy. Now we'll get started with Blender proper. First of all, let me turn on the screencast keys so you guys can see what I'm doing. At this point, it's good to remind you to turn on Node Wrangler. You can do that in Edit Preferences. Unfortunately, my video capture software doesn't capture that window, so I can't show you, but just go to Edit Preferences, Add-ons, and look for Node Wrangler. Make sure it is turned on. Now I want a window for geometry nodes. So go in here, drag up this, and change this timing window to geometry nodes. And create our geometry nodes. Yay! So here's the thing that's universal about Blender. Sometimes when you do this with geometry nodes or a texture or anything with nodes, you'll see a blank window when you first create it, or sometimes when you first create it, usually when you come back to it. And if you see a blank window and you know there's supposed to be nodes here, the easiest way to find them without scrolling around, I mean, you can look at these scroll bars and get some sort of clue where things might be, but the easiest way to do is to select all with A and then hit dot, and that will center you on everything you've already created. Wasted lots of time before I figured that one out. We won't need this now. We'll come back to it at the very end, so I'm just going to kill it. So our cap is going to be formed with a line. So let us get a line, Shift A, search, curve line. Yay. And I know in the future we'll want to smooth this out a little bit. So resample is our friend. Set this up to something reasonable like 16. And now we have a curve, which is actually a straight line, but that's progress of sorts. We're going to create a curve and apply it to this line. So the way to do that is with a set position node. And this is where all of our lovely math will tie in to actually create the shape of the line. Okay, so because we're using a spline, we have a spline parameter node available to us. So I'm going to add one of those. Now this gives us the total length, which is going to be 1 because we're not going to change it. The factor, which is a number between 0 and 1, and this will gently increase along the curve. This is what we're going to use as the basis to affect the shape of the curve. And this we will plug into a cosine for the x and a sine for the y. This is where Node Wrangler really shines. So let me just go ahead and undo that real quick. So like I want a math box. I want to change the function from the default of add to sine, and I want to hook up this factor to it. So what I could do is I could do Shift A select for a math node, put that in here, and then change the function to sine, S-I-N-E, and then hook this up. You can do that, it's fine. Not very efficient. But if you use this feature and I just search for sine, I get all that done in one step. This has sped me up more than any other tip I've seen on Blender. Okay, now we have the sine and cosine. These are going to be combined to we use a combine XYZ node to put these together. And these are going to be hooked to the set position node. And now we have the beginnings of a curve. Now, because the radius is constant, this is a perfect circle. Because this factor runs from 0 to 1, and again, Blender almost always uses radians, that means we get 0 to 1 radians of a circle. And because an entire circle is 2 pi, this is about 1/6 of a circle. This doesn't matter, but it's just kind of nice to understand what's going on. Now we'll start to add the first of our mechanisms to reshape this curve dynamically. What I want is the ability to change the amount of this curve we're using. So right now we're just using this section of it. Maybe if I want a flatter mushroom, I want to use just a little bit of the curve. If I want a longer mushroom, I want to use more of it. So now is a good time to put that ability in. So I'm going to use no wrangler, hold shift, right drag. That joins those noodles together. And in between here, I want to put in a multiply. Hook this back up. And then if you don't want this anymore, you can Control X to get rid of it. What do we want to multiply by? Anything. I mean, you can see here, it's like, so this basically controls the amount of the circle we get. So if we make it 2 pi, we get the whole circle. If we make it pi, we get half the circle. I don't know what I want right now, but what I do know is this is going to control the shape of the cap. So I'm going to hook this up to just a value node, and I'm going to give it the name cap bending, because the overall effect will be to adjust the amount of bend or curvature of our cap. I love this feature in Blender because it serves two things. One, it's kind of like documenting your code. It lets me know what this is going to be for in the future. Plus, when I get done with the project, as you saw in the final file, I'm going to want to have things parameterized over here. So the last step of a project is to look for these little red boxes I've created. And I usually move them off to the left as I create them so I can keep track of them easier. And this lets me know what I'll want to parameterize in the future. And in the meantime, it's just a good way to play with it and monitor my progress as I go along. So now let's put in nodes to control the other two aspects. So I want to be able to scale this along the y-axis, and I also want to be able to scale it along the x-axis. So I will add a multiply node. Shift A, search for a math node. Change this to multiply. So this one will be controlling the x. So in the future, this will be width. So I'm going to create yet another value node. And this will in turn get multiplied into the x value. So I'll just hook this into x, like that, and that. And this also needs to be applied along the length. You see it's 0, so we have no bending. We have no thickness, I'm sorry, but we can change that. Yay. Right now, just go ahead and set it to 1. And now we want to do the same thing for the y-axis. And this will be the cap height. Kill that, and then join this up and join that up. And join that up. So this had another intended/unintended consequence. Because we are multiplying these values by the original values, when these are 0, the multiplication forces the initial coordinate back to 0, and that puts our starting point of the curve now at 0, which is actually very close to what we want. But now we have these nice handles. So by doing that, we can adjust the width. So now we have our nice parameterization on a curve. This is the cool one. So this is what changes like from the flatter mushrooms to the curvier mushrooms. And of course, we'll never use that much of the curve. But, now, so in order to make this into a 3D shape from a 2D shape, we will use a curve to mesh. And specifically, I'm going to use a curve to mesh on a circle. So basically, we're going to take this profile curve and sweep it around a circle to create the mushroom cap shape. So let's do that. Shift A, search for curve. This will form the basis of our rotation. And run this into a curve to mesh. The profile curve, the thing that we're actually sweeping around the circle, will be the curve we just created. And now let's see what we got. This is close. You'll see there's a big hole in the center. This is one of the things I discovered through trial and error. So there's no obvious way to control the position of the curve you're sweeping around the circle. So I experimented, as I finally figured out that if the curve starts at x equals -1 and finishes at x equals 0, then the beginning of the curve will be at the center of the circle and the end of the curve will be at the edge of the circle, and I'll get the nice shape I want. So because our origin is currently at 0, I just need to move that to -1. And I only need to do that in the x. So I will add a math node, stick it here, and then we'll change this to -1. And there we go. Bit weird for the first one, but theoretically, if I change the width, yeah, look at that. And then I can go here and use a little bit less of the curve to get more of a flat. Now we are off to the races. So that is the beginnings of a mushroom. This is a lovely start for the shape of the cat. Next thing we need to do is give it some thickness. We need to do this for two reasons. One, just the basic appearance of it. If the mushroom cap is just a perfect plane, it'll be pretty obvious. But also, we want it to have two sides so we can separately texture the outside of the mushroom, the top side of the mushroom cap from the inside of the mushroom cap. We also want to be able to separately texture the inside and the outside of the mushroom itself. So, what we're going to want to do is use a set position node. So what we're going to want to do is to take this shape and duplicate it and then stitch the edges together. So what I would really want is a solidified node, but those don't exist yet. So to create two copies of this is as simple as anything. You can just, I'm going to get rid of this for now, split it. So we're going to take one and use it where it is, and we're going to take another and do a set position on it to offset it from the original. Now, if we were working on the XY plane, I could just offset it in the Z a little distance and do that. The problem is we're working with curves and they're in every conceivable axis, so we can't do that. So what I really want to do is move the second copy out along the normal. The normal is just a vector that always points away from a surface. So this way it'll point away from the surface regardless of what happens to the curve. So that's very easily done. I could just give it an offset of the normal. Okay. And then if I put our two things back together, I can do a join geometry. Yay! Now we have two copies of our curve. That is way, way thicker than we want. So let's give ourselves a way to control this a little bit. Easiest way to do that is to scale this vector, scale the amount we're going to offset it. So I can just type in, maybe I can type in, get a vector math node with scale. Again, that goes into offset. And now we have control. And as we did so much before, I'm going to give this a meaning. I'm going to give it a value, just a way to control it with a name that I select. So F2 to select the name. I'm going to call this cap thickness. Now, this is not apparent now, but one of the things I've learned is I want really fine control over this. And the standard float is way too powerful. So while I'm thinking about it, I'm going to stick in a divide node. And divide this by 100. So now I have a lot more fine-grained control on how this looks. It's not so important now, but it'll become hugely important in the future, and it's nice just to go ahead and take care of it while we're here. Speaking of taking care of it while we're here, not really ready to talk about texturing yet, materials, but this is a really good time to prepare in advance. So, like I said, we want to have the inside and the outside of the mushroom textured separately. So while we're thinking about it, while we're here, let's just go ahead and search for a set material node. Duplicate this. I'm just going to leave these be, but at some point we're going to come back and call one of these inside, one of these outside, and apply material to it. Okay. So we have our two surfaces. Now we need to join them together. There's a couple of ways you could do this. What I could do, and it works pretty well if they're close together, is take this one edge and use a set position basically to move the last ring of vertices on the interior one and basically just slam it to the exterior one to create a knife edge effect. This is the way I originally did it. I didn't like the visual look of it. So even though it's a little bit more complicated, what does look a lot better is to actually create new faces between these two surfaces. It's a little bit tricky, but actually less tricky than I thought. Okay, so, and because you heard me mention a while ago, we want to do the edges, we need a way to find the edges, and Geometry Node gives us that. It gives us that with a node called vertex neighbors. Now, in the center of this mesh, if we turn on wireframe for just a second, boy, clear as mud. You can see each of these vertices has 4 neighbors. So anything that has less than 4 neighbors is an edge. Nice. So we can take the vertex count and we can do a less than and set this to 4. So now we have a way to select edges. So now we have 2 copies of original surface that divide here. So this is the first copy, this is the second copy, we've divided them. What I really need now is a third copy. And this one I'm only going to use to grab the edges, separate them away, and then merge them back in. This will make more sense in a second. So I need to separate geometry node. What I'm going to do with the separate geometry is I'm going to use it to just take one ring of vertices and extrude it to meet the other ring of vertices. Which vertexes do we want to use? The ones that we just selected. So now you can see we just have the exterior ring of one of the surfaces. We want to extrude that. We want to extrude it from here to here, or either way, doesn't matter. just from one to the other. This turns out to be a fairly easy problem. If I can get the position of a vertex on the outside surface and the vertex position of the nearest vertex on the inside, and I subtract them, now I have a vector that tells me how to get from one to the other. And all I have to do is take this ring and extrude it along that vector. Geometry Nodes provides a really easy way to do that. So we know we're going to do a subtract. So Shift A, search, and I need a vector math node because this is all going to be 3 coordinates. And I know that one of the things we want is the position. This is the position of one of the vertices on the ring we just created. Now what we want is the corresponding vertex on the other surface. This can be done with transfer attribute. And what this will allow me to do is grab some values from one surface and use them to the other surface. But first we need to tell it which vertex. There's several ways to do that, but the easiest one is nearest. So basically, Blender will go searching for the nearest vertex on the geometry we tell it to look in. So in this case, it's going to be the original geometry. So we're going to be going from the one we offset a little bit back to the original. And the attribute we're looking for, well, this attribute is position, so this one should be position as well. This should be subtract. And what we are going to do is extrude it. Using an extrude mesh node, this might be a 3.2 or a 3.3 feature. This might not work on 3.0. I don't think I ever tried this trick on 3.0. So we take this vector that we created. Basically, it tells us how to get from that ring to the other surface. We'll use that as an offset. Now, the default on extrude mesh is faces. We don't have faces on our little two-dimensional ring. We have edges, so that's what we want to extrude. And if all is right with the world, nice. So we get this band that is perfectly sized to connect our two surfaces. Now, we can just collect this with everything else. And now we have a solidify modifier, a wonderfully generic solidify modifier for geometry nodes. There's one last little detail. You can leave it like this, but it is nice to merge the final nodes. So what we've done is basically we've taken these surfaces and we've put them adjacent to each other in space. In order to create a single surface out of it, we can merge by distance and fuse it into a single piece of geometry. Okay, I know I said just one more little thing, but there's just one more little thing. You notice how this edge is a little janky with the polygons, with the quads being in kind of weird orientations. There is an easy fix for that, and that's to take on this transfer attribute. We don't want to get the attributes from the points, we want to get them as edges. And you can see that nicely cleared things up. Basically, it forces Blender to connect the adjacent edges rather than just like searching around on a point-by-point basis. I don't know why they're not the same. I would think Nearest would take care of that, but maybe some Blender expert can tell me. Before we leave the cap, I want to add some more interest to it. So what do people reach for to add more interest? A noise texture. Yay. Run this into a set position node. And hook it up. and properly hook it up. And we get garbage because that is way too much. So in order to turn this down a little bit, let's go ahead and scale this. Now we have some control, but as I always have to be reminded when I work with noise textures run from 0 to 1, and in order to keep our mushroom in the same place, we really want something that is balanced around 0, so like minus 0.5 to plus 0.5, or anything that's balanced. So in order to take care of that, it's just really easy to subtract. And we want to subtract a half. Nice. So now we can get a more pleasing result. Now I know from past experience that one of the things I always want to play with is this. So I'm going to add a value. This will eventually be exposed in the interface, but this allows me to control the scaling on the noise texture. So, and theoretically I could expose both of these. It hasn't really been, I never found myself really wanting to mess with this too much after the initial creation. This is usually fine. And generally, I mean, in this particular application, you don't want too much garbage. I usually leave this around a 2.5, but this will be fine for now. And that is the end of the cap. In the next section, we will tackle the gills. See you then.